My name is Katrin, and my current position is I'm a PhD student in Tübingen in Andreas Geiger's lab, working on autonomous driving and currently language and this combination. Yes, yeah, I recently won the Best Presentation Award at the summer school in Sicily, and yeah, I'm really happy about that. Yes, so I presented Bland, my paper from last year, Choral. And basically the work is about to have a learned planner. So we're in autonomous driving. And autonomous driving is basically, you can do it with a modular pipeline. And there you have, you have sensor data. Then you have a perception module because you want to perceive the environment around you. And then you have a planner, and the planner basically takes the perception output. So basically all the 3D detections of all the vehicles. And the goal is to generate a path. So like a trajectory where the ego vehicle should drive. So for example, if a vehicle in front of us is braking, we also want to brake. And this planning module is often done, for example, a rule-based planner. So you basically have to handcraft rules for every possible scenario. And what we did now is we created a very simple model which does this in a learned way. So we collect data, and then we have a neural network which basically processes that, yeah, or learns to plan from data. Yeah, I would say there are, let's say, two things. One is about the planning in general. So many works before did this learned-based planning with an rendered image. So you have an HD map and you render your detected vehicles in there, and then you use a CNN. And then there were some works which does it's similar to us with like more graph representation or like an object level representation, but mostly quite complicated architectures, and also only evaluated offline. So most works did similar stuff, so it's nothing fancy new, but they didn't evaluate online. Like online driving means in simulation, we want to evaluate the car driving around on not just as in a like offline data set, because there were some works saying basically that these metrics doesn't correlate very well. So it's very important to evaluate online. So basically what we did is we have a really simple model, which can basically be a baseline for a lot of extensions, which is nice because it's like not super complicated to implement or complicated to understand. And therefore it can be used for, I don't know, now there is this new Bland challenge, or also now many people working on combining language with driving. So it could be used for that because we're using a transformer network and we tokenize our scene. So it would be also possible to just also input language tokens, for example. So I think that's a really nice thing with our work, that it's super extendable and very easy to use. And yeah, so that's the first thing I would say. And the second thing is that we have this explainability part in it. So we use this transformer for planning, and a transformer always has these attention weights. And we basically looked at attention weights if we can use that for explainability. So we basically visualized attention weights. We visualized basically how much attention the network pays to each of the other vehicles in the scene to make the decision. And then we also proposed an evaluation scheme to evaluate if these attention rates are really explaining the decision, because there's a lot of like discussion in the field if attention is really explainability or not. So we thought, okay, we can't just say, yeah, we're doing that as explainability, but we really want to evaluate. And the result was basically, okay, in our case, we don't even want to generalize that. Just in our case, these attention weights can be used for some kind of explainability. So I would say also from what there were like 3 winner, or like first, second, third place, and also what I saw from the others. I think we had the most non-standard posters. So it was like a poster session, and then a voting, and then the presentations, right? So the posters were like not what you see all the time at poster sessions, where you just have the heading and then some boxes with the content, and that's it. Basically, all 3 had some kind of fancy layout. So for example, my poster, I have like, I don't know, 1/3 of the poster is just a red bar with just the title, my logo from the project, which I created with Dolly, and the QR code. And then I'd only have like a smaller piece for the content, where I only have the really important stuff. So I think it's like an eye catcher, like if you walk around and then you see all these papers and then you see, oh, here's something different. So I think that makes a difference. And that was also something the others had. They also had like this not so standard layout. Yeah, and otherwise, presentation wise, I don't know if I done a so much better job than others. I guess many people there like did a great job in conveying what they did and explaining in a clear way. But I think that's also part of a poster session and presentation, to have like good structure and yeah. So actually we already started to extend it a bit. So we had like the last half year, basically after this work was published, 2 master students working on some extension, where we have this planning module. What I described was the main part. But then of course the question is, what happens if we have a perception module and the perception module makes errors or introduce some noise? So basically we want in the end a complete driving stack. We want to go from sensors to actions. So we need perception. And that was basically now the part of this like small follow-up works, that we also created a good perception module, basically to have a full modular pipeline. And then we saw that at least till now, the results are still valid, that we still get like this really good performance we got in this privileged setting when we have like ground truth information as input. But then if we use a perception module, it gets basically similar performance. But that's currently like ongoing stuff still. And other than that, I think there is like, now we have this modular pipeline, but in research also there is a lot like going on in end-to-end driving. So I think that's these 2 like ways of doing it. And I think it is currently still not really clear what will solve autonomous driving in the end. I think some people are very sure this one and others say the other. But so there would be a way of like combining, basically, since it's so simple, to combine basically the approaches, that you have a modular approach, what we currently have. You have like a LiDAR, you have object detection, and you explicitly input these detected objects to our planner. But in addition, since we're using Transformer, we could also still input image tokens, and then this would be the end-to-end part. So we could basically combine these 2 approaches. Also, I think some people are currently working on RL. So there, I think it could be also used as a very simple baseline, since we don't have like these huge models which do perception and everything in once. You can just do that as a standalone, and go basically from a privileged setting. Mostly RL is used to create experts, which we then imitate with another network. So if the expert is privileged or use privileged information, it's basically not a big problem. Depends what you want to solve in the end, but in some settings, this could work, and this could be a good starting point basically for trying that out. Actually, maybe also a bit unconventional, or I don't know if that's so good to say, but I'm not like full into vehicles and cars and that I like cars so much. It's more like that I like this research area because there's so many things to do. I can basically do whatever I want and do it on self-driving. And I like this applied thing. So before I started my PhD, I thought I want to do something a bit more applied where I see it could be useful and not like super theoretical stuff. That's just not me, I would say. And then in driving, you could do just vision. You could combine vision with like control and robotic parts. Now I'm combining it with language. So I think there's so much options to explore different areas and different things and combine them. So I think that makes it very interesting.